efficient way to get to the temperature which you want to have in the zone. So, for example, if you want to have 21 degree in your room, we find a way to, as efficient as possible, get to the 21 degrees, and that's the key thing. How we can optimize the energy consumption. Next slide, please. By turning equipment on and off if it's needed. And finally, this has a huge impact on 4 different levels. First, we have the capabilities to decrease the carbon footprint. The standard is between 20 and 40%. Increase the life of HVAC equipment because we use it more efficiently. So that means you have a higher lifetime value. Improve the thermal comfort of your building, so we can make the building more comfortable and have a better CO2 and humidity level. And then finally, reduce the total energy costs up to 25% related to HVAC. Next slide, please. And then another thing, and again, Stefan mentioned that today, it's demand side management. So what we can do is we can use the technology and make buildings work together in order to predict the capability on the grid and do proper load balancing, avoid peak times, and so on and so forth, by shift the load and the demand accordingly. And again, this is where we use our technology supported by cloud and AI that helps us to make the building more intelligent. Next slide, please. And where we do that, I think that's a very significant thing, is we're dealing on a global level, having an impact on hundreds of buildings globally. And we're increasing our footprint heavily, and having headquartered in Montreal, we do have 160 employees focusing on making the world more sustainable with our technology. And happy to follow up with some of you after that call, who wants to dig deeper a little bit on how we can make an impact on your building stock. Next slide, please. And finally, I brought up one concrete example just to get you a feeling. It's this a building in London where you see some quite significant numbers, how we can achieve the savings. And the interesting part is, as it is a software as a service, you have no upfront investment cost. You plug in our technology, we charge per square meter, which we control. And finally, you're gonna gain the first savings after a few weeks after installation. And that's key thing as well. What we learned in the last conversations is that speed is very critical. And besides the technology, we want to bring that speed on the market as well to make a fast impact on the buildings. Next one, just to give a feeling, this is what I said before, is this is an office building. The right one is a retail building. So we really see that, especially in the retail space, the cooling demand is increasing. So that's why obviously our impact has to be better and better, as if we increase the cooling demand in buildings because of the energy higher temperatures, we need to have an impact on that, and this is where we can heavily influence. And there is office and retail as a huge gap to fill. So that's it finally from my side. So thank you so much for your attention. Just feel free to scan the code and reach out to me afterwards. And let's make the buildings smarter, greener, and more efficient, starting by today.
Yeah, thank you very much, Martin. Thank you very much for giving us these insights. I know you have to hurry a bit, but yeah, just send him a message if you're, like if you have any questions for him in the chat, and yeah, there he can see them. So next we will have Esther Kizaritsky with us. Esther is General Manager for Rubitherm Technologies GmbH. Since 2020, she is also the CEO of the Egyptian branch Rubitherm LSC, together with her colleague Karim Shaha. Besides the daily operative work on and with PCMs, her main focus is developing smart solutions using PCMs and raise the public awareness of the material possibilities. Welcome to our conference, and we look forward to your presentation, Esther.
Thanks for the introduction. Yeah, so phase change materials were already mentioned earlier in Stefan's talk. If you were listening really carefully, they came up when he mentioned that there's not only thermal batteries as storages, but there are also many other energy storages possible, and one of them is using phase change materials. So I will start really right in the beginning because I'm not sure everybody knows what phase change materials are. Next slide, please. So the simplest phase change material you can think of is water. If you think of the phase transition ice to water, so solid to liquid, happening at 0 degrees Celsius. And within this phase change, you really need a large amount of energy to do this melting process. It's the same energy needed to actually heat up the water afterwards from 0 to 80 degrees. So the phase change makes it necessary that I need in a small temperature range a large amount of energy, and that we can also use to store energy, to use it later on, for example. So that's what we are looking at as phase change materials. Next slide, please. And just to show you a comparison here, how high the energy density of phase change materials compared to other materials. If we look at a temperature interval here of 15 Kelvin, and now you see the water on the left side is much smaller than the ice transition, because here we are only looking at the sensible heat that's stored in water in this 15 Kelvin range, and then phase change materials compared to other materials have a high storage density and can also be used to increase the thermal load of buildings. Next slide, please. So yeah, looking at the kind of materials we are using, in principle, almost all materials have a phase change at some point. What we are looking for here, especially in the range of building applications, is maybe phase changes that happen between -10, -20 degrees and +50, 60, 70 degrees Celsius. And here we do have two product groups that are usually mentioned. Those are ones of the organic kinds, so they are similar to waxes if you touch them in the solid state. And the inorganic class contains mostly salt hydrates. Well, all of them liquefy during phase change, and as we don't want them just running away from the buildings, we have to encapsulate them in some way. And on the lower part, you see on the right side the so-called PCM packs. So it's usually a polymer encapsulation that's also used in buildings, but very common also in the transport sector to keep things cool during transport. And on the left side, you see a very special encapsulation. It's a aluminum metal encapsulation, and we call it the compact storage module. And next slide, please. That's actually the one I will talk about now in some applications. Next slide, please. So what can we do with these CSM panels, with the phase change materials in buildings? Just look at the picture on the upper half. You have like a stack of these CSM panels. Just imagine you have a melting point of about +21 degrees Celsius. And during the night, when it's cold outside, you suck in cold air to kind of charge these panels. They cool down, they solidify, and during the day, then when it's getting warmer outside and you want to keep it comfortable indoors, but you still want also some fresh air coming in, you can kind of guide warm air over these panels to cool them down to keep comfortable temperatures inside. Next slide, please. So if you don't want to have any stacks, we have some prefabricated stacks here. It's called a phase cube. It holds 10 panels per box and can easily be installed in existing air ducts. But of course, you can also build your own stacks to whatever dimensions are needed. Next slide, please. This is a different application where the panels are actually used in combination with a chilled ceiling, where the panels were kind of put on top of the ceilings, and the copper pipes with water running through were cooled, or had the possibility to be cooled down, was cold night air as well. And that was actually monitored for more than 5 years in a science center in Bavaria. and they could see energy savings up to 40% by peak shifting from the day to the night. Next slide, please. So this was kind of on a small scale. One can also go much larger and think of applications in warehouses where excess solar or wind energy can be used to charge phase change materials, here shown in purple on the top. So you use that when you want to keep food at a certain temperature, or also other goods that are temperature sensible. Next slide, please. And then just, by the example, if you use excess solar energy, then during the day you would charge and during the night you would discharge. Of course, if you use wind energy, times might differ as the wind is usually not blowing much stronger during the day than during the night. This can be used to kind of as a standard to kind of do this peak shifting, but one can also use phase change materials as a backup system during power outages. Next slide, please. Similar application is also possible for server rooms. It's the same principle as seen before, so we will just jump to the next slide, because everything we saw so far was basically air-guided systems. But if you say, well, I do have a huge climatization system, AC system in my building, and it's the heat transfer medium is water or water glycol, then you don't want to put some panels somewhere. Then it's much easier if you have a larger storage tank somewhere, and this can also be filled with phase change material. You need a different heat exchanger than you would use for a standard water storage tank. But in principle, it's from the outside, at least, it looks like a standard storage. It has a much higher storage density in a small temperature range compared to water. The lifetimes can also be much larger than for electrical batteries. So this can also be combined with other renewable sources in the surroundings. Next slide, please. There are some examples here where these systems have been installed. We can just jump over that. So these were kind of all examples or applications on the cool side. Of course, PCM is also of great use in heating applications. I'm not going into that today. That's for another time. Next slide, please. Yeah, that's the take-home message, in my opinion. If you need a thermal battery, think of PCM. It's one possibility. If the temperature levels are of the right, if they are the right niveaus given, then PCM is a great solution. Thank you.
Yeah, thank you very much, Ista. That was interesting to learn more about the phase-changing materials we don't see every day, and it's interesting to see what's happening there. And now, we've started a bit late, and we're probably a bit like you need a coffee. So we want to have a short coffee break of 15 minutes, and we will go back into the networking mode soon. And then we will start with the second part of our conference. We look forward to seeing you there. Leander, can you bring everyone back to the networking mode for the coffee break? So we will be there in 15 minutes, which will be 2:20.